Greetings, welcome back. In our last class we have discussed additive rule and we have said it works very closely with what we have covered in union of set. In this class we are going to look at multiplicative rule, which is an extension on conditional probabilities. So let's go ahead and look at it. It is built on conditional probability. So recall probability of event A given B, and we have said these two events are dependent, because if they are not dependent, then probability of A given B is equal to probability of A. But for dependent event, probability of A given B, we have said is equal to joint probability, that is probability of A intersection B divided by probability of B. And we have said probability of B should be something greater than 0, because if it is 0, then it doesn't make sense. All right, so multiplicative rule is an extension of this rule. So what if we want to get joint probability out of here? So probability of event A and B happening together, we were given the probability of A given B, and we have the probability of B. So the probability of these two events happening together, or joint probability, is equal to probability of A intersection B, all right, will be equal to just from simple, elementary mathematics, A given B times the probability of B. All right, just from here you multiply both sides by probability of B, all right, and here you multiply by the probability of B, all right, the probability of B, then this cancels out, and probability of A intersection B, which we call joint probability, is equal to probability of A given B times the probability of B. Great. Now let's take an example. I don't want to say you gamble but let's take an example on a game. Let's say you're a fan, you're a football fan, okay? Imagine you are watching your favorite England soccer team and want to know how likely it is that they win. Okay, you're watching your favorite team and you want to know if they win. So let's assume you don't gamble, or you don't try to predict for money anyway. And your favorite player Mohamed Salah will score. You want to see if they win and Salah will score. And you know that this season the team has won 80% of the game he scored in. All right. Furthermore, you know that he scores 70% of all games. He scored in 70% of all games. So I think we have some information. Let's say A is team winning. Team wins. And B is, let's say, Salah scores. Salah score. Okay, team wins and Salah score. So what we are looking for is probability of team winning and Salah scoring. So the joint probability of team winning and Salah scoring is what we were asked. And we know that probability of team winning given Salah scores is 80%, so it is 0.8. And probability of Salah scoring, he scored 70% of the game he played this season. So probability of Salah scoring is equal to 0.7. So the probability of A intersection B will be equal to probability of A given B times the probability of B, so times the probability of Salah scoring, right? Which is equal to probability of A given B is 0.8 times the probability of Salah scoring is 0.7. So we're going to have probability of team winning given probability of the team winning and Salah scoring is 0.56. 0.56. This is a good probability. There is a good chance, an average chance for Salah scoring and team winning. So in our next class, we are going to look at Bayes' theorem, what we have been building on, and it will be an extensive class that you cannot miss. I hope this is helpful. Thank you and enjoy learning. See you in our next class.